Can you hear me now? Yep, good to go. Great. All right. Thank you. Apologies for the technical difficulties. Um, my name is Tony Janisek. I am the state engineer for water resources and the dam safety program manager. Just a reminder that all mics have been muted unless you are a presenter. So if you have questions, please put them in the chat. This is our first virtual dam safety workshop. We plan on having future workshops. At some point in this workshop today, you'll have the opportunity to provide input on future workshops. And so if while you're listening, if there's anything that we don't cover or that you would like covered in more detail, please provide us with that feedback when we give that opportunity. And so the purpose of this workshop today is to provide dam owners with information on the safety needs for their dams, as well as to provide information on what the dam safety program does. And so if you take away anything from this today, I would like it to be that the dam safety program is here as a resource for dam owners. And so if you have any questions on the safety of your dams, please feel free to reach out to us at any time. And so this workshop is structured into 7 sessions. There are some sessions have multiple presenters, and we have a total of 6 presenters. I'm not going to introduce them all here, but they will have a chance to introduce themselves as they present. And so with that, we'll get started on our first session, which is dam safety in Oregon. Give me 1 second to get my presentation up. All right. So dam safety in Oregon. So in this presentation, I'm going to cover the requirements for regulation, hazard rating of dams in Oregon, an overview of the dam safety program, and our program authorities. And at the end, there'll be a few minutes for some questions. In order to be regulated by the department, a dam needs to meet both a height and storage requirement. Dams need to store at least 9.2 acre feet, which is about 3 million gallons, and it's based on the water right. And dams need to be at least 10 feet in height. This height measurement is taken along the center line of the dam, measured from the crest down to natural ground. And the schematic on this slide shows how that height measurement is taken, and that's usually done from the drawings or from estimated from measurements taken in the field. And so all dams that are regulated by the department are assigned a hazard rating, which is based on the consequences if the dam fails. And so there are 3 hazard ratings: high, significant, and low. For a high hazard, we expect loss of life. For a significant hazard, we don't expect loss of life, but we expect extensive property damage. And for a low hazard, we don't expect loss of life or property damage. The slides, or the images on this slide, show the aftermath of a failure of a significant hazard dam. There was, in Oregon, there was about $2 million worth of property damage, but no lives were lost. So the hazard rating at significant for this dam was correct. There are a total of 939 state-regulated dams in Oregon. Of those 939, 76 are high. The slide shows the distribution of dams, state-regulated hazard rating in county in Oregon. And I would like to point out that there are another 12,000 alternate reservoirs, which are reservoirs that are too small. They don't meet the height and storage requirement for regulation. So there are a lot of dams in Oregon, but only 939 are regulated. And so that total number of 939 can change from year to year as new dams are built and dams are removed. And so in addition to the 939 state regulated dams, there's another about 240 federal dams. And so the department has limited involvement with federal dams, mostly because these dams are already regulated by a federal dam safety program. And the 5 federal agencies listed on this slide have dams in Oregon and a dam safety program that regulates those dams. This image, the map, shows the distribution of state versus federal dams in Oregon. So the dam safety program has 6 core functions. We inspect dams to identify safety issues, and following inspection, we follow up with an inspection letter that provides dam owners with recommended and required actions. And so start out by trying to work with owners cooperatively to get those required actions completed. However, if a dam owner is unwilling to complete required actions, we have enforcement authorities that help get compliance. We also have a role in emergency planning and response. This is largely around high hazard dams. All high hazard dams are required to have an emergency action plan, which is a document that tells what to do in an emergency. And they're also required to exercise those EAPs periodically. And so we are fairly heavily involved with that. So even though significant hazard dam owners and even to a lesser extent low hazard dam owners aren't required to have an EAP, it is recommended that they do just so that you're prepared in an emergency. We also administer contracts and grants. The contracts and grants go towards funding dam safety engineering analyses, as well as rehabilitation work for safety-related issues. We also do in-house investigations and engineering analyses. And we also review designs, review and approve designs. So our program authority is contained in the Oregon Revised Statute, Chapter 540, and the Oregon Administrative Rule, Chapter 690. These in 2019, our statutes and rules were updated for the first time since 1927. So there were a lot of changes. These changes became effective in July of 2020. And so some of these major changes are that we have limited authority for federal dams. There are now well-defined requirements for design reviews and approval. And so these are for new dams, modifications to existing dams, and for dam removals. Roles in emergency planning and incident response are defined for dam owners as well as for the department. And we now have a well-defined criteria for determining hazard rating and for changing hazard rating dam breach inundation analysis, which is a computer simulation of what happens when a dam fails. So dam owners are also now responsible for notifying us when dam ownership changes and also to provide updated contact information. And in the rules, there are also requirements for dam owners to maintain their dams. And as I mentioned, we always prefer to work cooperatively with dam owners, but if dam owners are unwilling to complete required actions, we now have authorities for civil or criminal penalties. And so this is just a slide with my contact information. If you need to contact me, please feel free to reach out. And this slide has two resources, a link to our dam safety program webpage and also our state inventory of dams. And so with that, I will open it up to any questions. Okay. It doesn't seem like there's any, oh, maybe something. Sure. And just to note that all of the presentations, so all the slides are available for download. And also Linda sent them out through an email. So if you want them, they're also there, but I'll put that back up. And so I assume there's,
Sorry, Justin, you can go ahead. Due to the amount of people in the call, instead of raising your hand, just go ahead and type your question in the chat, please. Thank you.
nope. Okay. So it doesn't seem like there's any questions. Oh, there it is. Um, all right, 12,000 alternate dams. Are these non-jurisdictional? Are they registered with the state? Just the same. So the alternate reservoirs, as I mentioned, are not regulated by the department or by the dam safety program in the department. They do require a water right. And then, often through the water right, there are some conditions based on the water right. Other than that, they are not regulated by anyone, but they are registered through their water right. So, question about storage requirement, is that only permanent impoundment storage, or would temporary storage? No, so that is the, and we'll get into this a little bit later. That is the amount on the storage water right, and which would be the reservoir level at normal pool. And again, we'll talk about that a little bit more later. So does administration of grants include making funds available to dam owners for repairs? It depends. Right now, the only funding sources we have are from FEMA, and they only go towards high hazard dams that are in poor and unsatisfactory condition, which there's only, I think, currently like 20 or 21 right now. So it's very limited now. Can we access the master list to see if any of our storage lagoons are listed as a dam? Yes. So the link, one of the links I provided on the resources slide, has a link to our state inventory, and that's where you can search for state regulated dams. Are beaver dams regulated? No, they are not. Okay, so it's 8:15. It is time for our second session. If there are any additional questions come in, we'll answer them either at the end or I'll follow up afterwards. And so the second session is on, let me pull up the agenda, is on hazard and risks of dams. And so I will turn it over to Keith. And Keith, please remember to introduce yourself.
Hey, I'm Keith Mills. Can everyone hear me okay on this? Okay, it's good to be here. This is one of my last tasks working for the dam safety program. Prior to this, I had Tony's job, and I've worked for the state for almost 41 years, and so I'll be retired after today or maybe after early next week for good. So, but it's really good to be here and talk to everyone. So I'm going to go over first dam safety features, and those especially that are important for hazard and risk of the dams. And so I have slides that follow that show each one. I'm going to go over here what some of the main terms are, and then I'll show you a number of figures on what those are. So most of the dams that the Oregon Water Resource Department regulates are embankment dams. And so they're made of soil. And that's important because that they are vulnerable to certain safety issues. So the next feature I'll go over is the spillway, and that's for passing major flood flows. And on some dams, there's more than one spillway. The crest of the dam is the top of the dam. What's that? Oh, I didn't share it. Okay. Okay, it's not okay. It's not doing it. It's okay. I got it now. Okay, sorry about that. That I thought I was sharing the screen. So again, talking about a number of dam safety features through the spillway, the crest, and the embankment. The freeboard is another very important feature of a dam, and that's the vertical distance between the water level at the reservoir level and the crest of the dam. And there's a number of different freeboards that we call out in our inspections, and we'll describe those in more detail later. The conduit is normally at the base of the dam, and it's for normal water releases, not the major flood flow releases. And then I'll be talking about zones, filters, drains in a dam that lower the internal water pressure in the dam, and we'll have a couple presentations on that. Talk about slope protection for preventing surface and wave erosion, and show what those different options are for slope protection. Show you the abutments of the dam, which is the natural ground edge of the dam, and the toe of the dam, which is the natural ground downstream at the base of the dam. And so here we have a dam, and I'll show you the main features are the crest of the dam right here. And that's just simply the top of the dam. It's not the top of the spillway. I once had a owner report that the water was flowing over the crest of the dam, but they really meant it was just flowing over the spillway, which is a very big difference. Here we have the abutments. They're the sides of the dam. So this is one abutment. This is the other abutment. The toe of the dam is right down here. This is the downstream face of the dam here, and this dam is covered with grass for its slope protection. And then for spillways, and this dam has two. It has what is sometimes called a principal spillway. Which is, let's see. So the principal spillway is sometimes this interior drop inlet spillway. And then there's a conduit that goes through the dam. A lot of dams do not have a principal spillway at the upper end. We do have a conduit through the base of the dam. This is the outlet of the conduit, and then there's a valve typically on the top of the dam here, or sometimes there's a valve at the outlet works here. So those are some views here, and then this is how we measure height of the dam, and it also shows the spillway. So the height, this is a section sliced right through along the long side of the dam. So this would be the top of the dam. This is the original stream channel. In the very middle of the dam, we measure the height from the top of the dam to the lowest point in the stream channel in the middle of the dam. And that's an important measurement. And then normally, Tony talked about it, when we measure storage, storage is normally from this low part of the spillway and everything that's stored at that point. And that applies to any type of dam. We regulate lagoons and temporary storage facilities that may not store very often, but we still measure the storage the same way to that point. A very important term for all dam owners is freeboard, and that's the distance, vertical distance from here to here, from the water level. So this is the water level of a dam right here, the reservoir level. And this line here is the top of the dam at the low point in the dam, top of the crest. And so you can see this dam has probably only 2 feet of freeboard. That's insufficient for a larger dam, and it's insufficient for a high hazard dam. And then we have this second photo here shows a dam with a nice rock face for erosion protection, and then a lot of freeboard here. So we're on for this dam, we're talking approximately 10 feet of freeboard, which is normally a freeboard that we'd like to see on a larger dam, at least the normal freeboard. One thing to point out is that that freeboard changes as the water level goes up and down, and we'll talk about it in the inspections presentation on the minimum freeboard and how we estimate that. But for all owners, one thing, when you get a very small distance between the top of the reservoir and the top of the dam, we have increasing risk to that dam. So here's a couple pictures of spillways. We have, this is a normal condition for this spillway. This is a dam in Wasco County, has approached here, and then we have a concrete control section here that controls the water elevation, and then this is the discharge channel here. This is at typical conditions, and then occasionally we have an inspection or a special inspection at a very high flow level, and this is the storm in 2012 at Silver Creek Dam. Next, we have conduit controls, outlets, and drains. I have a control for the valve here, and what we can see is one of our water masters operating that. The dam owner was somewhere on that inspection too. So that's what we call cycling the valve, and that's really important. We'll cover that later. And then here we have the outlet pipe. So at the out base of the dam on the downstream side, this is the outlet pipe. This is a pretty new dam, and this has also 2 nice toe drains here, filtered toe drains. And next is that I want to cover is a little bit about dam structure. So again, these are embankment dams. This is the upstream face of the dam here. Looking at a bigger perspective, this is a spillway. This is the McMinnville Water and Lights Dam. And this is a fairly new dam in really good condition. And then we have This is another embankment dam that was just cleaned of vegetation. You can see the downstream face. This is their control building where the outlet pipes are. And now I want to get into the hazard rating of dams. And so Tony talked about that to introduce it. I'll talk a little bit about why we have it that it's based on the potential impacts from a failure flood downstream of the dam. So that's very important. We're looking at what could happen if that dam fails. This was a partial failure on this slide of a dam close to Salem about 7 years ago, right before Thanksgiving. And there were a number of workers below this dam at the time of the partial failure. All the water was released, but fortunately the dam did not fail quickly. But again, we're looking downstream at the impacts. And Tony went over these, the hot hazard ratings for dams. We have high, again, is just where we expect loss of life to occur if the dam fails. And that's defined in statute. That ORS is the statute reference. So statute is state law. Significant hazard rating means we do not expect loss of life, but we do expect extensive damage to property or public infrastructure. That's also in law. And then low hazard rating means that if the dam were to fail, loss of life would be unlikely and damage to public or property or public infrastructure would not be extensive. And that's defined in rule. And those references are in the slide here. So hazard is not risk. I'll talk about risk later. Hazard, again, is what happens if the dam fails completely in a rapid failure. It refers to people, property, and public infrastructure, especially homes and busy roads. And this is an example of a school bus driving below a dam. This dam is listed in unsatisfactory condition. We're working with the owner on rehabilitation of the dam. And so it's one thing that sometimes hasn't been looked at in the past so carefully is busy roads also provide a risk to people. Tony went over this slide. It's flooding from a 2006 lagoon dam failure near Hermiston. The dam was rated significant hazard, and the damage was significant on this failure, so it was correctly hazard rated. Inundation analysis is required by rule for us to change the hazard rating of a dam, and for all new dams, the engineer working on that dam needs to submit an inundation analysis. And what it is, it's what's called a hydrodynamic analysis, determine the extent of flooding downstream of the breach and also the depths and the velocities. And so it's done with a pretty complicated computer modeling software. That's the one we use the most is Corps of Engineers software. And then we get maps like this. That includes areas flooded with the blue, and then flooded to 2 foot depth in the red. And we look a lot at the 2 foot depth and velocity for our hazard rating change, especially for a high hazard related dam. What's based on hazard rating? So this is important. So design standards for construction and modifications, the design flood, the design earthquake, and internal erosion prevention. The standards for each of those change based on the hazard rating of the dam. So what's required for a new dam or for a modification of the dam will be quite different depending on the hazard rating. The inspection frequency changes. We inspect high hazard dams every year, significant every 3, and low hazard every 6 years. And then for the annual fee, it's different for each of those hazard ratings. And we also have a design review fee for new dams. In terms of risk to dams in events, the most dams fail in an event. And they may be, those extreme events are floods, earthquakes, and landslides. And I'll show a few of these in the next few slides. So the first is a extreme flood. On this photo, this illustration here, we can see the satellite image from a storm that hit Oregon in November of 1996. I was working for the Department of Forestry then, and it had very heavy impacts in Douglas and Coos counties, including a couple dams that got overtopped, but it also caused a number of landslides that had severe effects on people. So in Oregon, our largest floods have occurred in 1861 and 1903. The 1861 storm was an atmospheric river up and down the West Coast. The 1903 event was an extreme thunderstorm. Many floods are expected during the life of the dam, and the dam needs to pass the largest flood flows without overtopping or other damage. So again, as I talked before, the spillway is an essential safety feature. It's probably the most important safety feature on the dams because dams made of soil fail if significant flows go over the crest of the dam. And next is a feature that causes dams to have distress and sometimes fail are earthquakes. And what I'm showing in this photo here is the Cascadia subduction zone. That's this line right over here, and there's a small plate off the coast. This Cascadia subduction zone, when I went and got my second engineering degree in geotechnical engineering at OSU, that wasn't believed to make large earthquakes. It was thought to slip slowly all the time. Well, that's now known to be incorrect. The last major earthquake occurred in January 1700, and there's an approximately 0.3% annual recurrence probability of this earthquake occurring. It'll be around a moment magnitude of 9. So that's our biggest concern in Oregon, but we also have a number of other smaller active faults in the Willamette Valley, around Klamath Falls, and also in Northeast Oregon. And again, earthquakes cause different kinds of deformation in dams. So now those are the events that would cause dam failures, and now I'll talk about the actual failure causes. So one is overtopping in floods and spillway destruction in floods. And those two combined make up about a little over 45% of all dam failures over the last 100 years or so worldwide. And they also have caused a number of dam failures in Oregon. The second big factor for dam failure is internal erosion at a very high reservoir level. And those also count for a little over 45% of all dam failures over the last 100 years. So that's a very big percentage of failures. Seismic liquefaction and deformation only has resulted in a few percent of all the dam failures that have occurred. However, in Oregon, especially near the coast, it's very important, also in the Coast Range, because of the Cascadia subduction zone. And so we're at higher risk, especially in those areas. The next one is landslides, and parts of Oregon are very susceptible to landslides. And the last one is disrepair of the dam. And I'll just show a few examples of those. This is a dam on the border of Clatsop and Columbia counties. What you can see here is the crest of the dam. This dam filled up to the crest, just about overtopped in a 2007 flood. Here we have the log boom. This entire log boom broke in that flood right after this picture. Somehow all the logs and all those boats that are behind the boom went through that interior spillway without the dam fail, which was pretty amazing that this dam did not fail, as sometimes luck is on your side. And then spillway destruction. About 7 or 8 years ago, there was the Oroville Dam, which had major damage to both of its spillways due to some design issues, which is interesting because Oroville Dam is the highest dam in the United States, and it's in California. It's owned by the Water Resources Department down there, but somehow they missed a few things on that. Luckily, the dam didn't fail, but resulted in 100,000 evacuations. And then spillway deterioration, we have a number of dams, including this one that I showed before, that have spillway deterioration. And then have internal erosion. Teton Dam was the really big dam that failed in 1976 in eastern Idaho. And this entire failure developed from the first seeps to the failure in 4 hours, including the rapid failure in about 15 or 20 minutes. And then seismic deformation. This is the example is the Lower Van Norman Dam that failed like this in 1971. It didn't fully overtop, but the dam was destroyed, and it was hydraulic fill with loose sands, and they're most susceptible to seismic deformation. And then this is a landslide on this photo. This is the landslide here. It's a very large landslide. This is an image from LiDAR, which removes all the vegetation so you can see under the trees. You really couldn't have seen this without these trees being removed. So this landslide went down here and went all the way down this channel, and actually the dam was built in this spot. This is the dam. It's 700 to 800 feet long, and it was built in this spot partly because the channel was narrowed by the landslide. And the owner did remove this. They felt the risk was too high once they knew that the landslide was there, because there was potential for another failure to actually take out the entire reservoir. And then the last cause of many failures is disrepair and misoperation. This is a small dam in Baker County. The owner did not do any dam maintenance. This dam failed in 2011 in my first month working for the Water Resource Department and dam safety. There were low spots on the crest. There were large trees on the dam, and there were burrows from ground squirrels throughout the dam with badgers digging for those, and none of those had ever been repaired. And this did cause downstream damage to property downstream. So conditions that increase risk of dams are undersized spillways, random and poorly compacted materials, corrugated metal pipes, and we did not know the cascaded subduction zone and some other faults were active when some dams were built. So corrugated metal pipes, these are typically used in highways and logging roads, but they're also common in some dams. They corrode very quickly. These were pulled out of a dam. There's no bottoms in those. They leak and eventually collapse and can increase the risk of dam failure. We have irregular materials. This is a dam in Wheeler County near the Painted Hills, and the dam itself looks like the Painted Hills. It's actually supposed to, so you can see the different colors here, and different gradations, gravel here and fine grain materials here. And I'm not even sure what this is, but this was done to dig out the conduit through the dam, the corrugated metal pipe, and they found that this dam had no core in it, and also was irregular, so very prone to internal erosion. We have these conduits in failure here. This conduit is eroded out in the bottom. You can see the erosion here, and then there's in this other conduit, we have water squirting up here from one of our inspections, and it had internal erosion developing in that. The owner has since repaired this one. And then one thing that internal risk detection can be difficult, so we can't find in our dam safety inspections what's going on in the middle of the dam. And so this requires, in this case, drilling through the dam. And this dam was another dam where we found it was not constructed with the compaction that was indicated in the design, very soft soils in a very high seismic zone, and owners working to try to find resources to replace their dams. So one option is if it is too expensive to rehabilitate and the water is not really needed, removal of the dam can be one option. And we learned a lot from removals. This is a dam dam in Tillamook that was removed, and this is a 6-foot diameter cedar stump that was buried in the dam. Dam had a lot of other defects in it that weren't shown on the drawing. So some of our dams were not constructed the way we would construct them now. But we do have also many dams in Oregon are well constructed and maintained. This is a dam in on the border of Yamhill and Washington and Tillamook counties. Nice rock fill. It's a municipal water supply. And this is a private dam also in Northwest Oregon. Got a great well-maintained vegetative cover and a big spillway here. So that's a brief introduction to risks of dams, and I would be happy to take any questions now.
Keith, would an overflow into a wastewater process be considered a spillway?
I've got one above it too. Oh. And so I've got questions here. What kind of geotech testing was performed at the dam that was shown at Newport? And that was drilling with SPTs, Shelby tube testing, and also cone penetrometer testing throughout the depths. And Newport has 2 dams, and they were done on both the dams. And I have a question. Would an overflow to a wastewater process be considered a spillway? It depends on the specific dam, but whatever keeps the dam to a safe level is normally at not high inflows is generally considered a spillway. On some of the wastewater dams we have that are low in significant hazard, we tend to discourage sometimes spillways if they have a leak detection system. Spillways are required on any high hazard dam and any dam in a channel. And then hazard, the next one is hazard does not equal risk. How do you quantify risk? So the dam safety program conducted a detailed risk study of a number of those dams that are FEMA eligible, that are high hazard dams and significant in a poor or unsatisfactory condition. We looked at all those features and looked at the condition of the dam. For overtopping, we looked at the best hydrologic analysis we could do and figured out what return flow would overtop. And then we looked at the number of people down below and what the number of people that were likely to be in the inundation area and the number of people that were likely to be in the high risk inundation area that couldn't get out. And then we just did an annual risk, and FEMA has document on risk, and we submitted our report to FEMA. So on our highest risk risk dams, we did that in a simplified manner. And how often are small neighborhood dams required to be inspected for erosion? So if it is statutory dam and it's a low hazard dam, we inspect those every 6 years, and we provide recommendations to the owner on those dams. For some small neighborhood dams can be a significant hazard. We even have a couple that are high hazard, and those are every 1 in 3 years. And those actually, given there's a risk downstream to people or property or public infrastructure, if there is maintenance that's needed, the owners need to take those actions. And so our regular inspections, next ones would regular inspections identify internal erosion? No. And so what we would look for internal erosion are holes in the downstream where there's been material moved out, and sinkholes, but many times internal erosion does not show itself that way and can develop fast. So really, we tend to look more at how the dam was designed, and I'll get into that in this when we talk about the soils a little bit later in this presentation. And how do you quantify rodent damage to the lagoon? Well, in our inspections, if we think it's serious, we tend to probe and find the depth and the extent of those. If they're only a few feet into the dam, it's not generally considered too serious. But if they dent in the dam or dig through that, as certain of our burrowing rodents do, then it can be really serious. And I'll explain which are the most damaging animals a little bit later in the presentation. And I think that's all my questions. So I'm going to turn it back to you, Tony.
Make sure you turn the mic off. Okay, thank you, Keith. So our third session is on maintenance and operation. It's going to be split into 3 different parts by 3 different presenters. Our first part of this session is on spillways and conduits. And so in this presentation, I'm just going to define spillways and conduits and provide some terminology, and then go through issues and maintenance related to both spillways and conduits. And so what is a spillway? A spillway is an essential safety feature of the dam that allows for safe release of water from the reservoir. Oh. Apologies, thought I shared my screen, but I did not. There we go. Okay. So a spillway is an essential safety feature of the dam that allows for safe release of water from the reservoir to either control the water level or prevent overtopping from the dam. And so, as Keith mentioned before, there are 2 types of spillways: the principal spillway and the emergency spillway. And so often dams only have 1 spillway, and in that case, it's essentially just the emergency spillway. And so the principal spillway controls the normal pool or the water level at the storage water right. And so, for example, if the dam has a water right to store 100 acre feet, the normal pool is the water level at that 100 acre feet. And so a principal spillway has several different names. I've listed some of them here. And I'm not going to read them all, but there are also other ones, and I put them here just so that you have reference, because you may come across these at some point, and they're all just different terms for the principal spillway. And so the emergency spillway, from a dam safety point, is one of the most important safety features of the dam, as I mentioned. And that's because it allows the passage of large flood events, and it prevents overtopping. And so the emergency spillway is also known as the auxiliary spillway. And so again, this is just a configuration of the two different spillways on the dam. So this is the principal spillway. It controls the water level of the reservoir at this level here. And when a large flood event comes in, the water level rises and flows out the emergency spillway. And so this is just another configuration of the two different spillways. This principal spillway goes over the top of the dam. And again, this one's controlling the water level, and this one releases flood water. And so spillway terminology, there are three main parts to the spillway: the approach, control, and the discharge. And so this image here is just this area that's circled here blown up for clarity. And so the approach is the part of the spillway that directs water away from the reservoir toward the spillway control section. So it's the very beginning of the spillway. The control section is the part of the spillway that regulates the flow of water through the spillway. So the dimensions and the characteristics of the control section are what determine the flow rate into the spillway. And so finally, the discharge is the part of the spillway that directs water away from the control section and away from the dam. And as Keith mentioned, freeboard is another important term when talking about dams and spillways. And so again, it's just the distance from the water line to the crest or the top of the dam. And we have three different terms for freeboard that we use. The normal freeboard is the distance at normal pool. So the distance at the bottom of the primary spillway, the invert of the primary. Is it back? Is the audio back? All right. Where did it cut out? Was it on this slide? Okay. So minimum freeboard is just the distance from the high water line to the crest of the dam. Screen stopped. Let's see. Okay, we're back. All right. So this slide is just another way to illustrate the current and the minimum freeboard. And so you know, during an inspection, this is the water line that we observed. And so the distance from the water line at the time of inspection to the crest of the dam is the current freeboard. And this here is the high water mark. And so the distance from the high water mark to the crest of the dam is the minimum freeboard. And so as Keith mentioned as well, flashboards are another component of spillways. And so flashboards are essentially just an obstruction that temporarily increases the storage of the dam. And so here, these are wooden flashboards, and you can see that, you know, these are in place, and now the reservoir level is higher than it would be if they weren't in place. And the picture on the right shows an engineered flashboard structure, and these are all made of metal. Okay, on to spillway issues. So a blocked spillway. So it's just any obstruction within the spillway, anywhere within the spillway, that reduces or prevents flow through the spillway. And so as Keith mentioned, and as we talked about with spillways, the function of the spillway is to pass large flood events. And so if it's blocked, it can't do that. And then the dam could overtop and then could fail. And so the cause of a blocked spillway is debris accumulation during flood events or after wildfires, or due to vegetation growing in the spillway. And so the picture on the left on this slide just shows a blocked spillway. The picture on the right shows a spillway that is filled with vegetation, and it's kind of hard to tell, but here's the reservoir, and here is the discharge channel through here, and you can just see the discharge channel is just filled with vegetation. And so to address a blocked spillway, you essentially just need to remove debris. And one way to assist in doing that is to install a log boom. And so a log boom is just a series of logs strung together. And you can see them in this photo on the left. And again, here on the photo on the right, strung together, and they catch debris. And here's all the debris that it's catching. And the other way is just keep vegetation out of your spillway. And so this is a before and after picture, roughly from the same point of view of the same spillway. And so you can see in the after picture this well-defined spillway channel. And in this picture, you can't even really tell what's going on here because there's just so much vegetation. Another safety issue is spillway erosion. And so spillway erosion is just degradation and damage of the discharge channel due to the force of flowing water. And so the reason this is a safety issue is that if erosion continues, it could eventually make its way back to the dam and cause a failure of the dam. And at the very least, it would prevent you from storing water. And so the causes of this are a lack of protective cover, which would either be grass, rock, or concrete, or due to some type of obstruction in the spillway that concentrates water and facilitates erosion. And so the picture on this slide shows the spillway. So the point of view of this picture is standing on the dam looking down the spillway. So the water would flow from the dam this direction down. And you can see the spillway, all sides and bottom of the spillway are eroding. And so to address that, first you need to fill in material that has eroded, and then establish a rock or grass cover. You can use concrete as well, but that is typically prohibitive for most, cost prohibitive for most dam owners. And so one of the most important things is when doing work on your spillway, you always want to check with us first because we want to ensure that you're not, the work you're doing is not reducing the capacity of your spillway. And so the image on this slide shows a spillway that has a rock cover on the bottom, and here on the sides, they are working to establish a grass cover. On to the conduit. And so Keith touched on this a little bit, and I'm just going to go in a little more detail. But the conduit is an essential safety feature of the dam that allows the reservoir to be lowered in an emergency. And so the conduit also allows you to release water to use it, but from a dam safety perspective, it's that it lowers the level in an emergency. And so there are two types of conduits, a low-level conduit and an intermediate level conduit. The images on this only show a low level, and it's called a low level because it's at the lowest point in the reservoir. But an intermediate level conduit would just be a conduit somewhere through the middle of the dam. And so a low level conduit is far more common than an intermediate level conduit. There's three main components to the conduit. The conduit itself, which is just the pipe that conveys water. The valve or gate, which controls flow of water into the conduit, and then the control stem and wheel, which allows you to operate the gate. And so while all dams should have a valve on the upstream side, some dams have a valve on the downstream side. And so it's important to note that dams that have a valve on the downstream side need to be designed in order to do that, because the conduit becomes pressurized and that adds additional safety concerns. So If you don't have one on the downstream side and your conduit was not designed for that, you cannot put one on the downstream side. And so these just show some real world pictures of what I just mentioned. So here's the control wheel. Here's the control stem that goes down into the reservoir that connects to the valve. And so here's the stem here that's connected to, in this case is a gate. This gate slides up and down over the opening to the conduit, which is right here. And this picture here shows just the downstream side of the dam. So we're looking back at the dam, which is right here, and this is where water exits the conduit. So conduit safety issues. Corrosion of the conduit and controls. And so this is largely due to age, environmental factors, and conduit material. And so the reason this is important is that if you don't have a functional conduit, so if your gate's not working, you can't operate it to release water in an emergency. And also, if the conduit itself is corroded, as Keith showed some photos of conduits with holes in them, that can result in internal erosion. So through those holes, water carries dam material away from the dam, and that could eventually lead to failure. And so one of the most important things you can do is cycle your gate or valve annually. And so what that means is that you fully open and fully close the valve or gate one time per year. And it's important to note that if you haven't operated your conduit in more than a year, operating it may result in a sediment release, which could trigger a water quality violation. And so if you haven't operated your conduit in more than a year, and you plan to do so, you need to check with the Oregon Department of Environmental Quality to figure out the best time of year and any requirements associated with a possible sediment release. And so because the controls in the gate are made of metal, they corrode over time. And so they need to be repaired and replaced. For the conduit itself, the only way to assess the condition is to scope the interior periodically. And so what that means is that a special camera is inserted into the conduit and it takes a video of the full interior and length of the conduit. And then from that video, an engineer can view it and make a condition assessment. And so over time, because most conduits are metal, they corrode and deteriorate, and they eventually need to be repaired or replaced. And so for most dams, the lifespan of the conduit is somewhere between 25 and 50 years, depending on the age, environmental factors, and the type of material that it is. And I'll get into repair and replacement after this next slide. And so these images just show screenshots from different conduit scopings. And you can see this appears to be a steel pipe that has corrosion here at the top. This is a corrugated metal pipe here that has a lot of corrosion, and you can even see some holes here. And this image shows a concrete pipe. And so this is two sections of a concrete pipe that are joined here at this joint. And this looks to be what are probably roots that are penetrating through the conduit. And so as I mentioned, if you get your conduit scoped and it shows that there are issues with it and it needs to be replaced or repaired, the repair option is what's called a slip lining. And so what that means is a smaller pipe is stuck into the conduit and the space between them is filled in, it's grouted. And so in this image here, you can see the original pipe here, and this is the new pipe that's being inserted into the conduit. And so again, here is the original conduit. This is the original conduit here, the new pipe that's been inserted, and this here is the space in between that has been grouted, typically with some type of cement-based material. And it is important to note that slip lining is not possible in all cases. So sometimes conduits, they can deform, and if they deform enough, you can't actually get another pipe inside. And so, and in other cases, the conduit, the original conduit, is just too small from a dam safety perspective to have another pipe inserted inside. And so in those cases, the conduit needs to be replaced. And so what that means is the old one needs to be dug out and removed, and a new one replaced, and then the dam rebuilt. And so here you can see this is the dam here. The dam extends all the way through here, and they dug out essentially a V here, which you can see here. And the old conduit was ripped out. This is the new conduit that they're working on installing. And once they install this, they're going to build the dam back up to the original height. And so another safety issue related to conduits is erosion at the conduit outlet. And so this is caused by the force of water and lack of energy dissipation. And so you can see here, this is just minor erosion. But all along here, you can see that material is being eroded. And over time, that will get larger and larger and begin to cut back into the dam. So the dam is back this way. And so the reason it's a safety issue is that over time, as it cuts back into the dam, it can cause issues with seepage and internal erosion, and also stability issues. And so how you address that is you need to add some type of energy dissipation. And essentially all that is just lining the outlet with rock. And so you can see in this image, a small pool is created and rock is just placed on the bottom, and that dissipates the energy and prevents further erosion. And so this is an example of that. So this is the same conduit. So here's the conduit here, and here's the conduit here. And you can see in the before picture, all of this is erosion. So all this area has eroded away. And in the after picture, you can see where the owner has just placed a lot of rock. And this has been in place for, I think, at least, I don't know, 3 to 5 years now. And so it seems to be working. Typically, you would probably place rock down here and over here as well, but this seems to be working, so it's fine. And so with that, I'll open it up to any questions on maintenance of spillways and conduits. Do you have a camera to inspect conduits during annual inspections? We do not currently have a camera. We plan to apply for grants at some point, probably in the next few years, to try to get one. That would be the ultimate goal. But as of now, a private company needs to be hired to do that. Does OWRD prefer to slip line conduits versus CIPP, or is that situational? So that is situational. I'm not very familiar with CIPP applications in dams. And so I don't think we've had one yet. Yeah, Keith's shaking his head no. We haven't had one yet, but I know they exist. But I guess if we really don't have a preference, we just don't have experience with CIPP. Is it mandatory for a dam to have a gate valve? So if you, I guess I'm having trouble understanding that question, because if you have a conduit, you need some type of valve, or you wouldn't be able to store water. If you don't have a gate valve that's a gator valve that's operational, then yes, we do require that it be operational. Does OWRD have standards requirements applicable to slip lining? No, we don't have anything in statute or rule. The owner would have to hire an engineer to design the slip lining, and then we would review and approve that, as that would be a modification to the dam. Do you leave it up to the dam owner to exercise the valve, or does the inspector check it when they inspect the dam? So no, that is the responsibility of the dam owner. Obviously, when we're on site, it would be great if we could see the valve operating, but that's not always possible, because sometimes, for an irrigation dam, sometimes we're there at a time where the owner doesn't want to open the valve because they need the water. And there's other reasons sometimes why the owner doesn't want to operate it when we're there. But obviously, we would prefer to see it, but if not, we take the owner's word for it. Okay, I'm not seeing any more questions. So the second part of this, again, this is a 3-part session. I'm going to turn it over to Keith for that.
Okay, this session, I'm going to be talking about the embankment, the soil in the embankment, and what features are important about that embankment. I'm going to be talking about then plants and animals, since many of our recommendations in our inspections relate to plant animals, and recognizing the specific plants and animals that do more impacts and some control measures. So first of all, the embankment is soil. And so soil, we have particles of minerals. They may be grains or clay particles. And then we have spaces in between those. So all soils have these spaces in between them. Sometimes they're very small, sometimes they're bigger. And those spaces can be filled with either water or air. And when they're fully filled with water, there is some amount of flow that goes through a soil, depending on how big those pores are. So that's really important to remember. And that if it's fully filled with water, there is pressure that gets transmitted through that soil, and it tends to push those grains apart, a buoyant force. And we call that pore pressure, and that again builds up when soils are saturated, and that is when it builds up greater than the strength of the material. That's when we have mass slope failure or landslides. What we do to make soils behave better as a dam material is to compact that material. And if we don't compact that material sufficiently, it's more prone to leakage and a higher risk of sliding. It's weaker. If it's compacted too dry and too heavy, we have the potential for cracking of the material and internal erosion developing through the dam. So compaction, when it was originally constructed, is very important. This is a dam that's being modified and raised in Central Oregon. You can see the darker soils on this are where water was added, and the engineer was on site to ensure that that was the exact right moisture content, not over or under compacted. Why this is another feature of the dam that I talked about earlier is zoning. Zoning means there's different types of material used in different parts of the dam. And so this dam has a impervious core, so it's going to be a finer grain material, more clay-like material in the middle. And then these are what we call the shells, the upstream and the downstream shell. And these should be more open materials, better draining materials. And then one thing we look for on all high hazard dams now and some significant hazard dams is a filter. And so this is a filter and a filter blanket here. What this does is if there's cracks that develop here, then the filter traps that material so internal erosion doesn't develop. And then all these other features are just drainage features, but the really important thing to note is these, and also the cutoff trench. And the cutoff trench is below the base of the dam to keep water from flowing through it. And we don't want that cutoff trench too deep, because if it gets into a permeable material, sometimes it can allow water to leak out of the dam. So this is all important issues that if you're having a dam modified or a new construction, the engineer needs to take care of this and determine what kind of zoning is necessary. On many of our dams, in fact, most of our older dams are homogeneous dams. Sometimes they say they have a core. A homogeneous dam has the highest risk of internal erosion. There's no safety features for controlling internal erosion should that develop. And this is a slide from that dam in Tillamook. This dam on our drawing shows that this is supposed to be a core right here. Well, there's no core that we can see. You can see a lot of cobbles in this material. And then we have a change in materials right here around the conduit and wetter materials down there. So it's more like a lot of our dams are like a random fill. And so when I started I worked for the Department of Forestry for 27 years before I started working for the Water Resource Department. And I wasn't informed that some of our dams would look like an old logging road fill. So that was kind of a surprise, but we haven't seen that many internal erosion problems on some of our dams, but it does make up about half the 50 or so failures that Oregon has seen since we've had a dam safety program. And so it is pretty significant that some of our dams don't have these safety features. So it is important to look at those pretty frequently to see there's no new seeps or other signs of internal erosion. So what is internal erosion? It's flow through or under the dam, through the soils of the dam or the foundation of the dam. And because the water, all those soils have some porosity, if they're saturated, there's water flowing through that. And that water flowing has a seepage force, and it can move particles and eventually develops a piping hole. And if it has a roof, if the material above it is strong enough, that can progress to a pipe completely through the dam, like the Teton Dam failure, and another failures. And what happens for failures, actually that pipe enlarges and the top of the dam collapses, and then we have a failure. So we do see some signs of internal erosion that we can see during inspection. So one is an increase in seepage with a hole, and that's actually the photo on the left is a dam that the owner has modified. Tony showed a picture of that dam, and this dam now has it's raised and has a filter on it. So, and this has been treated where this internal erosion developing hole was developed. And the figure on the right is one of our former water masters, and she's in a sinkhole on a dam. And it's up to her elbow how deep that sinkhole is. And there was a few sinkholes on that dam. The owner chose to remove that dam. We found no easy way to repair that dam, and it was a high hazard dam. And then mass erosion, so soils are also subject to landslides, which is movement of a detached mass of soil or rock and may transition into a flow. This is that dam near Salem that had a landslide. On this, you can see this is the scarp of the landslide where the ground broke away and moved. And here's the outlet of the pipe, and it actually broke the pipe. And the leakage from this pipe was one of the contributors to having this slide. So this dam hasn't been repaired. The cost was too much for the owner. And so the slides can be of the downstream face, the entire dam, or the natural slopes above the dam or reservoir. And what makes the landslides more dangerous is as their size increases and their speed increases, and that is all very variable. Every landslide is very different. Next is surface erosion. This is from surface runoff or from overtopping or from seepage daylighting. And this is a dam that the owner cleared the vegetation off. We actually advised them to do that, but there was nothing else under the brush that was on the dam, especially a lot of gorse. This was in southern Coos County. And the dam was mostly sand, and sand is very erodible. Sand is a difficult material in dams for a number of reasons. And so dam safety will look at any dam that's built with sand very carefully, and it may not be able to be a safe material unless it's protected in a lot of different ways. And then this is a situation with overtopping that for a number of inspections, we didn't see it because this surface had been completely covered with blackberries, but this dam at one point did overtop. Fortunately, not enough to fail the dam, but it did develop this gully right here. And so for seismic risk, we really can't evaluate that in inspection at all. So that requires drilling and testing, looking for sand and other strain softening materials. The analysis for seismic risk is very detailed and very complicated. We have a few in progress right now for several municipal dams near the coast, and those have been very complex, needing a very skilled set of specialists to do that analysis. I'm going to switch gears now to plants and animals and why we're concerned. Plants and animals can damage embankment dams. Western states have experienced dam failures caused mostly by animals, but a few by plants. And we've had a number of dams in Oregon that have failed due to animal burrows or dens in the dam. Dams can provide animals food and cover, and so they can be a great place for animals to live if they have access. And they also provide a place for burrows and dens. And so some of the ways animals can affect dams or plants can affect dams are blocking spillways, and this is a spillway that's got a lot of vegetation in it, and debris has floated in and backed up there, and so the spillway has now very little capacity to handle a flood. We have burrows, holes, and dens and roots. Have a big badger burrow right here, and the badgers, in this case, we're going after squirrels. And then these are roots that are 60 feet away from a dam and 1 inch in diameter. And they're ponderosa pine roots. So another way we have a lot of impact from animals is trampling. This especially with cattle. They reduced the height of this dam by over 2 feet, so there was less than 2 feet of freeboard remaining. And they've done that on this dam twice already. Lowered that since I've been here, each time by about a couple feet over a period of like 10 years. And then this isn't a dam, but this just shows how big the root bowl can be of some of our conifer trees if they get big. So trees, if they blow over, can do a lot of damage to the dam in addition to just the roots. And then a final very important thing that vegetation can do, this is on a dam in Douglas County. We can't see anything of the toe of this dam or where the conduit is. This is all blackberries, so that person there is probably getting a significant number of scratches trying to find the pipe and to look for seepage. In many cases, we just won't do that until the vegetation is cleared. It's just not safe. So damage from vegetation, roots can penetrate the dam. Roots will eventually die and rot, and when they do that, they can provide a path for seepage through the dam. The vegetation also provides food, home, and cover for animals. They prevent observations of key safety features, and the bigger and the woodier the plant, the more the damage. So these are some of our big species of concern. Trees are obviously our biggest concern. So cottonwoods grow very fast and can take over a dam quickly. Ponderosa pine sends roots a long ways away from the dam. Aspens spread and have significant roots. They spread very fast. Juniper have potentially deep roots. Willows are really common on the upstream face. And they sprout. Big leaf maples, and then especially the firs, Douglas firs and other firs, when they blow over, they can have a major impact on dams. So the roots, this is ponderosa pine example. You can see the ponderosa pine. This is the ponderosa pine here. This is an excavator because this dam leaked due to animal impacts. And so this is 60 feet away from that ponderosa pine, and the roots went all through there. It was 1-inch roots there. So ponderosa pine especially can send roots a long distance. And then these are big leaf maples covering the downstream face and around the conduit. These need to get cut down. If the trees are over about 3 inches in diameter, it's important to remove the root bulb, but not the fine roots. And they are especially dangerous near the crest. In this case, they're near the toe of the dam. Also, there's some on the crest, but these are big leaf maples. If you cut these down without digging out the full root ball or using an herbicide, they're just going to resprout. And these have already resprouted once or twice. Excuse me. And for control of seedlings, this is a dam in Jackson County. The city of Medford owns this dam. And this is an excellent seed bed for trees. So you can see all the seedlings on this. One good thing about the conifer seedlings is that if you cut them below the lowest live branch, most of the conifers will not resprout at all. And so the owner was going to be cutting these right after our inspection. Then for vegetation control for woody brush and also for vines in Western Oregon, typically brush cuts once a year. Eastern Oregon, not so often. Can be at least every few years to be sufficient. Since they grow slower. It must not prevent observation of the ground surfaces, and the brush must be removed if it's providing cover for burrowing animals. And then the next best ground cover is grass. Grass can be a good erosion control measure. You can cut it by mowing if the slope is too steep, by weed whacking. And main thing on grass, we need to be able to see the surface, or at least changes in color of the grass for our inspections to see if there's any seepage. You want to protect this if you're treating with the herbicides, is not to kill the grass, but to just control the other vegetation. And so this is an example of a dam that is in Jackson County before and after, and the owner did a really good job removing vegetation from this dam. That's what we like to see, and still maintaining a grass cover. Now switching to animals and dams. Animals provide more significant damage to some of our Oregon dams. Reservoirs provide great habitat. They are associated with vegetation and food and cover for them. In terms of damage that I've seen on dams, these are the order of impacts I've seen. Nutria first, they're just in Northwest Oregon. Cattle, muskrat burrows, dens, beavers, ground squirrels, badgers, usually after squirrels or other rodents, and marmots and rock chucks. So the nutria, that's just a picture of nutria. The big thing about nutria is it's orange teeth and size about 8 to 20 pounds. They are imported as a first species, and they can be dangerous around small to medium-sized dogs. And they do a lot of damage. I've seen them burrow from one side of the dam to another, clear through a dam. And Yeah, a lot of damage. Cattle can be especially bad when soil is wet. In Northwest Oregon, especially this dam, they pushed the soil down. It actually steepened the slope and did contribute a little bit to that slide that occurred on this dam. And yeah, they on the dam to eat the grass growing on the dam. So grass cover when there's cattle attracts the cattle. Muskrat are more common in eastern Oregon. They live in the dam and reservoir, make dens in dams that are difficult to inspect. Since they're in this picture here, you can see the burrow can go from the underwater part of the dam into a den. And so they can make a lot of damage. Beaver are big, pretty easy to spot with a big flat tail. They can dam the spillway and entrance to the conduit and really burrow into dams. So for animal maintenance, look for any signs of nutria and exterminate those. Remove vegetation that provides them cover, keep cattle from grazing on the dam with fences or whatever else it takes, and remove muskrat and marmots if observed on the dam. Remove ground squirrels if the burrows are widespread. Remove beavers if they have placed any material in the spillway or burrow into the dam. And for very serious animal problems, relatively clean riprap is the most effective solution like this. So we, on these dams with good rock face cover, we see very little animal or plant damage on those. And so for long-term design, they're better for consideration. So if modification is necessary, and it may be for, in this case, a leak from a burrow in a den, or from slope failure, a large tree or burrow into the core area, excavation into the depth of fill that was damaged needs to take place and the fill compacted to the correct density and moisture content, and that is considered a modification of a dam that requires approval. Any questions now on soils in the dam, plants or animals? I'd be happy to take those.
There's 2 in the chat right now.
Okay, let's see the chat. Okay, so the first question is there a rule or standard on how to correct animal burrowing damage? So I normally don't consider it damage until it's a few feet into the dam, unless it's very close to the crest of the dam, since that's the shell of the dam. Once you get deeper than that, you do want to find out how deep it is and dig it out to the depth and recompact that fill. And then and if there's a large tree on the dam over 3 inches, to dig that out with the big roots, leave the finer roots, and also compact into that. That's just a general rule of thumb. Each animal is different. And if our engineers inspect it, they probably will look at the specific situation and give you a little bit of guidance on that. So trees at the abutments, how far away from the abutment should the trees be removed? Really depends on the species. For a lot of our trees, the shallow rooted trees and the brush, just a little bit off the abutment. The trees that are really bad at the abutment are ponderosa pines and cottonwoods. Want to pull those back at least 20 feet. Ponderosa pines, sometimes 50 feet may be appropriate. So really need to know what tree you have and if it has problem roots. Are there regulations, permits needed to remove animals like beavers? There's federal trappers. We just did a dam inspection down in Coos County, and they got a federal trapper to do that. There's no regulations for nutria. They're an invasive species. In fact, the regulation for nutria is you can't locate it. So you can always consider if you is relocation or extermination of animals that are causing problem, except for nutria, that you have to exterminate those. And I would contact ODF and W for specific details if some of those are considered fur animals, there may be some regulations on those. Are goats an option for vegetation on dams versus hand remove or herbicide? Well, you can, any way that gets the vegetation out effectively is fine with us. It seems like goats, in my experience, are a lot of work. You need to fence those, and yeah, if you do have, if you raise goats, maybe, but I'm not sure for other situations. Any suggestions? The next one's any suggestions how to eradicate nutria? Any lethal means. We've had owners carefully shoot those. They're pretty. They hold their ground and they don't hide as much as the other animals do. So the main thing is to spot those and to know that you don't have an option for relocation with a nutria. Yeah, live traps with carrots as bait can work for nutria, but again, with a live trap, you still can't relocate that anywhere. So any means with a nutria, a live trap, I would say more if you want to relocate beavers or muskrats. And I think that's it. Any other questions? With that, I think I'm done. Thank you, everyone.
Okay, thank you, Keith. And so the third part of this session is on safe operations, and I will turn that over to Arden. And Arden, please introduce yourself.
Yeah, hi everyone. New face for you. My name is Arden Babb. I'm a civil engineer with the department. I primarily focus on hydraulics and hydrology, including the inundation analysis work that Keith and I believe Tony previously mentioned as well. So I'll go ahead and share with you guys. Let's see here. And perfect. Okay, so I'll be going over maintenance and operations, safe operations of dams with you guys. Okay, maybe, yes. So general overview of what I'll be talking about, just general monitoring to be on the lookout for, operations and maintenance plans, why those can be helpful for you guys, even if they're not required on your dam. Some of the natural events that you might be on the lookout for, storms and flood risks associated with those, earthquakes, wildfires, emergency planning, and some of the documents you can put together to help with some of those natural events and just generally maintaining your dam. Steps you can take in an emergency if one were to happen, and then actions in an emergency, which sounds similar, but I'll differentiate those when we get through them. So in general, monitoring, you're going to want to monitor the items that Tony and Keith have previously talked about. That includes internal erosion. A couple more examples of what you might look out for the internal erosion. You could have these areas that are called sand boils. Basically, it's just material that's starting to move up through the dam and create these kind of puddles of material. You can also look for erosion on the dam itself, as well as sinkholes and a couple of those other options that Keith mentioned earlier. The biggest thing that we always recommend is to look for any changes, things that are out of the ordinary, anything unusual. Most owners see the dams a lot more frequently than we do, so you guys will be familiar with what's daily and what's changing week to week or year to year. You want to keep an eye out for any new or increased seepage that you might be seeing. I'll show a couple examples of what that might look like on a dam. New animal activity, any trails near the water, burrows, vegetation being eaten, things like that, and any cracking or settlement or sinkholes that you guys might see on your dam. So a couple indications of seepage, some examples here. You can see these large areas of green kind of in between these very dry areas of grass. These are good indicators that there is some water or increased moisture in your dam. Sometimes this is a standard. These maybe year to year look the same in every dam, but if you're seeing new vegetation or new growth that you normally wouldn't see, that might be an indication that we need to take a closer look at those areas. Another example showing a more extreme event of seepage progression. This you can see in the top image here. There's a fairly clean dam face, but you can see that there is quite a lot of water behind the dam. you can see that there's water starting to now flow through the material, and then that actually led to a failure of the slope. So again, this is a worst case scenario. Most of the time you're not going to see this, but it is an example of why if you start to see extra moisture, additional seepage on your dam, it's important to notify us and potentially work to get that repaired. So one of the ways that you guys can help yourselves prepare for an emergency or just keep your dam in good working condition is with an operation and maintenance plan. Operation and maintenance plans are required for high hazard dams. We will review those and work with you to make sure they meet our requirements. But some new significance or low hazards might also require them. We highly recommend them in formal plans just to keep on the property or with anybody who would be utilizing the dam, because you can have elements that will help you maintain your dam moving forward. Some examples of what might be helpful to include in an operations and maintenance plan, even if you're not required to have one. Excuse me. Procedures for operating your valve and lubricating it on an annual basis. Some standards for how to manage vegetation. That might just be notes that were, for example, provided by Keith earlier. It could be monitoring to ensure the dam faces stay clean, conduits and spillways are clean as well. Routine observations, so frequency of monitoring seepage, any deformations in general condition. This could also include normal seepage conditions. So most dams have water going through them, embankment dams to some degree, and as long as they're consistent and monitored well, then those are fine for us. You can also include a flood release plan. So that would be a plan for releasing water if the reservoir levels exceed safe levels. So an example of when that might occur would be during a large storm or a flood event. So it's important to be aware of weather conditions that are forecasted to result in these big storms. It's good to always make sure your spillway is clean and not blocked, but especially if you know that there's weather conditions forecasted to bring a lot of rain. An option potentially would be to open your valves before the storm to lower water levels to help with any inflows that come in. Be aware that water quality standards and other agency requirements need to be followed if we're doing that. And I believe there'll be more discussion of that in later presentations today. You can also consider having engineering analysis done to show when you might want to open those valves. For example, if you're expected to get a certain depth of rain in a period of time. The other important thing to remember is your flashboards. If your dam has them, they need to be out when it's specified in your certificate. If there's no specification on that time, most of the time that'll typically be the end of October to the beginning of April when most of those larger storms would be coming through the area. Another natural event that it's important to be prepared for are earthquakes. Keith briefly mentioned this earlier as well. It's not as common as flooding, but it's still important to be prepared for what those might bring. This larger map on the left-hand side, black lines indicate active faults in Oregon. So pretty much anywhere around the state, there's a potential for earthquakes. It varies by degree. Obviously along the coast with that dark red color, those are the highest potential for strong earthquakes, but they could be across the state. So after an earthquake, when it's absolutely safe to do so, be sure to check for any settlement or new seepage that's might have occurred on the dam. Additional tremors are likely, so always use caution. After the main earthquake, there could be smaller shakes. And then you want to continue checking for any of this damage in the following couple days. Settlement might become more apparent at that point, or additional seepage may be showing itself. An additional natural event to always be aware of, especially here in Oregon, is wildfires. This graphic is not specific to reservoirs, but it did a good job of kind of showing what might occur. So before a fire, vegetation and ground cover help absorb water that's dropped by clouds. In the event of a fire, though, it creates a layer where there's no absorption of water, so it starts to run off any faces of the dam or in the watersheds above the dam. So it's important to note that fires can not only impact the dam itself, but also in the watershed above the dam. So it's really important after a wildfire has cleared through, you want to check for any sediment or debris movement into the reservoir, especially if it was heavily forested and a lot of those trees have been lost at this point. You want to check the spillway frequently for blockage of those trees and large trunks. You want to monitor dam faces for any erosion that might occur, especially now that the water is moving much more rapidly, potentially off of your dam faces. Areas that have been severely burned, wildfire risks can actually last for 2 to 5 years. So this is more of a long-term monitoring plan that would need to be put in place for these wildfires. A couple preventative measures that could potentially help. You could always try log booms, especially if your basin above your dam has a lot of heavily forested trees. And then rock facing, as Keith mentioned, is great for preventing vegetation and animals. It can also help reduce that fire risk. So a few ways that can be helpful in planning for these situations. Emergency action plans, they're a document that assists owners and operators and local emergency managers with actions to ensure safety in the event of a potential or an actual dam failure. So these are required for all high hazard dams, and all of our high hazard dams currently have one that is updated periodically. Significant and low hazards can have one, and we highly encourage that they do. We have a template available on our website that makes it really easy. Most of the blanket information is there, and you can just input information relevant to your dam. These are really great to have because there's a lot of information that can help you plan. If something were to occur rapidly, you may not always know the best action to take. And so these are some of the elements that can be in an EAP to help you. They can help you identify what an emergency condition is. It can also help you determine the severity of that condition. You can have a list of contacts. That could be local contacts for the dam owners operators. That could also include us at OWRD. It could be the local emergency management group. And that's just running list of communication that you can easily access in any event. It can also include steps to reduce dam failures or to mitigate its impact. Typically, they'll have maps that show the inundation zone, so you have an idea of where the water would be going if your dam were to fail, and you can let emergency managers know that that's the location where the water will be going. These are usually shared with the local emergency management office, so typically they will have a copy of it as well. And then it also goes through steps for ending the emergency. So who needs to be contacted, what needs to be done moving forward. These are really great to have because in an emergency, if your dam has an EAP, you simply implement the actions that are specified in the plan. It steps you through the process, who to contact, and the best ways to go about that. Dams without an EAP, you need to immediately notify us if it seems like there's a significant problem that might be occurring. Where possible, anybody downstream that might be impacted, if you're able and safe to do so, you could let them know. If there is a potential failure or an active failure in progress, always call emergency services first so that they can begin evacuating people, as they'll have better access to all of that than typically a local owner or operator would. And then you want to take all practical actions that you can to prevent the failure, to do so safely. So a couple examples of actions that you can take. These are all going to have a pretty common theme, which is generally trying to get water out of your dam as fast as you can. If you have an experience with water flowing over the crest, you can place fill dirt, gravel, sandbags along the crest, and what that'll do is it'll help filter water into your spillway, and as opposed to going more over the crest of your dam. You also want to make sure to clear your spillway if there's any blockages with whatever equipment you have available and when it's safe to do so. If you're experiencing a landslide or a major deformation, be sure to open the outlet pipes if you're, again, able to do so, and work to bring either pumps or siphons to the dam to help get additional water out of that reservoir as much as you can. If you're seeing issues with internal erosion, again, open your outlets. If the outlet's damaged, we want to initiate those pumps and siphons. And it's good, another note with the emergency action plans is that you can have a list of suppliers who would have pumps or siphons available that you could call quickly and start to get that process initiated. If there's other issues, you just want to conduct a visual inspection of the dam, fully open the low-level conduit if there's any leakage that could cause the dam to fail, and then again, consider pumping or siphoning from the reservoir. And I think that pretty well wraps it up. I'll open it to any questions. If there were any while I was working, I can answer those as well, or defer them to Tony. Let's see. Let's see. I don't think I'm seeing anything.
Let's give it another minute, Arden, and see if anything comes in. And then just so everyone knows, we will be taking a 15-minute break or so, and as soon as we determine there are no more questions, we'll start that break. Okay, I don't think we're getting any, so thank you, Arden.
Yeah, thanks, everyone.
Let's plan on being back here at 10:05.